Fine. So my discussion is what is big data, why Hadoop, drawbacks with the current databases, Hadoop advantages, Hadoop scope and job market, and also I'm going to discuss about the PySpark. Yes. Starting with the big data. Starting with big data, right? Already we see big data, the name itself saying huge volumes of data, right? Huge volumes of data. Today, if we see how the data is getting stored, KBs of data, MBs of data, GBs, terabytes. But up to here, you should have seen KBs of data, MBs of data, GBs of data, or terabytes. But today, if you see data is getting generated in petabytes. Huge data like petabytes of data is getting generated. 1 petabyte equal to 1024 TB. Already 1 TB is a large storage unit, but 1024 TBs forms 1 petabyte. Examples of petabytes of data generation. Examples of petabytes of data generation. Talk about any banking sector like SBI or HDFC, right? Within the SBI, within the city, we see hundreds of branches. Within the entire state, we see like thousands of branches. Within the entire country, lakhs of branches for SBI. Again, in each branch, again, millions of customers. Again, each customer making multiple transactions. Again, each customer making multiple transactions per hour, per day, per week, per month. So here huge data is getting generated. Huge data is getting generated. Forget about this as banking sector. But if you take example of social media like Facebook, take example of Facebook, right? Millions and trillions of users for Facebook. Not only within this country, entire world, it has got users throughout the world. Millions and trillions of users for Facebook. In a minute, how many videos and posts are getting, how many posts and videos are getting circulated? What should be the storage capacity to store all those things? In a minute, how many posts and videos are getting circulated? I say. So huge data is getting generated, right? Not only Facebook. Today, if I talk, every application is generating huge data. Every application, like if I talk, Facebook, let's observe this, Twitter, Google. Okay, now check this, right? 1 second. We take just 1 minute a transaction, just to take 1 minute a transaction. In a minute, how many Facebook posts and what should be the storage capacity to store all those things? Facebook generating huge data. Twitter tweets keeps on generating. Twitter tweets, right? Twitter tweets keeps on generating huge data. And even if Google queries, everyone querying in the Google, right? Google queries, what is the data generated by it? Google queries. Not in MBs or GBs, in petabytes. YouTube videos upload, right? You're uploading YouTube videos. What should be the storage capacity to store all the videos? And if we talk about email transaction, email or Gmail transactions, email messages, right? If we talk about the email messages, what is the storage capacity? What is the storage capacity, right? To store all these email messages, to store all the messages, right? Even just now I was talking about bank transactions. Just now I was talking about telecom transactions or e-commerce transactions, like Flipkart or Amazon trans. Everywhere we say like huge data. huge data, right, in petabytes. We talk about this Google, and if we talk about the remaining things, right, more than 300 petabytes, the data is getting generated averagely, right, per month. So for storing this huge data and for processing this huge data, currently we have got databases. Currently we have got databases, right? Yes. Databases like Oracle, MySQL, SQL Server, all these databases, right? They're used for OLTP operations, online transactional processing for day-to-day operations. But the specialized databases, if you heard about Teradata, Netezza, Vertica, these are used for data warehouse purpose, for online analytical processing, okay? But for storing unlimited data, just observe this, for storing unlimited data storage, unlimited data processing can't be done by these databases or by specialized databases. They can handle data up to some extent, but unlimited data storage is not possible with this, right? With these databases, right? This databases are for the specialized databases. Yes. So as a sol as a solution to all the storage level problems and processing level problems, we have got a framework called Hadoop. It is going to provide Hadoop, providing two services, storage and processing. Right. Later I discuss about this Hadoop, but before that, how the data is getting generated. Assume this is your data in the current world, in the current real world, right? Yes. This is the data which has been generated. This is the data which has been generated from the last 50 years. It is available in the current real world. Assume it has been generated from 1974 to 2024. Two 2014 to 2024. If you see for the last 10 years and compared with the previous 40 years, only 20% of the data we see which has been generated in the 40 years, but 80% of the data what we are seeing currently in the real world has been generated from the last 10 to 15 years. Reasons for huge data generation, especially from the last 10 to 15 years means because of usage of technology, usage of smartphones, usage of internet. Today, if you see everyone using internet, and that too huge data is getting generated. But if you go to 1990s, if you see the data and how you used to carry the data, secondary storage systems, floppy disks, 1.44 MB. A floppy disk size is 1.44 MB. Yes. Means in that 1.44 MB, you should, but slowly floppy disk, compact disk, DVDs, USBs, right? Your storage is increasing. Day by day, data is increasing, and the storage systems also increasing. But today, data is reached to petabytes, not even GBs or TBs. Petabytes of data is getting generated. But for storing that petabytes of data and processing that petabytes data, you need to have proper storage systems, right? And for storing, not only storing, also for processing. Also for processing, right? Yes. Okay. So because of usage of technology, because of usage of in smartphones, because of usage of internet, right? Huge data is getting generated, right? And that too, what are the main sources from where it has been generated? Mainly three sources, right? Three sources of data. Social data, machine data, and transactional data. Third one is like transactional data. From where this data is getting generated means from social data, transactional data, and machine data. Observe the social data means data which has been generated. Data which has been generated, right? Yes. Data which has been generated, right? Yes. Okay. Social data. Data which has been generated from social websites like Facebook, Twitter, all this like such kind of data we call it as social data. And machine data, right? Data which has been generated by reading or scanning the barcodes, RFID chips. For example, if you go to a shopping mall for the items you purchase, a huge bill is going to be generated, right? Means by reading that barcodes or this RFID chips. Such kind of data we call it like machine data, and transactional data like day-to-day transaction like bank transaction, telecom transactions. Mainly these are the main sources, right, from where the data is getting. Social data. Next is types of data. Types of data and formats of data, right? Mainly we have got structured data, semi-structured data, and structured data. Data which is organized in the form of rows and columns in a structured format, like database tables, Excel files, all this we call it like structured data. Semi-structured data, which is not fully structured, which is not fully unstructured, like the XML files, JSON files, right? Yes. And unstructured data like chart messages, articles, images, videos, right? Types of data, structured data, semi-structured, unstructured data, like database tables, Excel files, XML files, JSON files, short messages, articles, images, and videos, right? Yes. So these are the types of data, 4 to 3 types from where the data is 80% of the data. But if you see today, that whatever that huge data which has been generated, mostly going to occupy this unstructured format. So the biggest challenge here, like to handle this unstructured and semi-structured data. So for that, normal databases cannot handle it. They can handle only structured ones. So for this huge unstructured data and processing this, we have got a frameworks like Hadoop, which can handle all varieties of data. Okay. As day by day data is increasing enormously, we need to have some proper storage and processing systems. So as a solution to all the storage level problems and processing level problems, we have got a framework called Hadoop. Hadoop is meant for two things, for storage and for processing. Hadoop is meant for two things, for storage and for processing. For storing, we use like HDFS. For storing, we use a file system like, okay. Before that, right? We talk about any technology like C or C++ or Java or .NET. All these, they are meant for processing. Talk about Oracle, MySQL, DB2, all these, they are meant for storage. All these are they meant for storage. So these are meant for processing. These are meant for means any technology. It is meant either for storage or for processing. Either storage or for processing. But Hadoop is meant for both storing and processing. Both it can perform storing and processing. So storage, for storage, does it use any database? Means no, it doesn't use any database for storing its data. It's going with a file system called Hadoop distributed file system. Hadoop distributed file system. And for processing, we are going with MapReduce, Spark. So MapReduce was used a lot. MapReduce, right, was used a lot. But now totally like Spark is used. MapReduce, it's a parallel processing engine, right? Meant for parallel processing. Okay, now Spark is very much used. So Hadoop for storage and processing, for storage HDFS, and for processing MapReduce or Spark. MapReduce or for when yes, when Hadoop is performing both storing and processing, what is the necessity of these technologies, processing technologies and these storage technologies? When Hadoop is able to perform, right, you may get a query. When you are going to store and process, then what is the necessity of this processing and storage technologies? Do you think they'll be away from the market? No. You need to clearly understand when to go for Hadoop. Hadoop is meant for batch applications. Hadoop is meant for batch applications. Hadoop is not for online applications. Hadoop cannot perform online applications. Batch applications are batch processing, right? Yes. Observe here, Hadoop providing two services for storage, HDFS, for processing, MapReduce or Spark. Hadoop is meant for batch applications. Hadoop is not for online applications. We cannot see for a single online transaction. If you have performed an online transaction, for the single transaction, Hadoop is not required. Millions and trillions of records. So there are two types of applications: online applications, batch applications. Hadoop is for only batch applications. Online applications means user interactive applications. User interactive applications means user gives the input. User gives the input means making a online payment. Booking a movie ticket, user compulsory required for these things. User gives the input here. But batch application means user non-interactive applications. Your user is no way required. Railway ticketing PNR status. Currently, your waiting status 200. After 2 hours, it is 120. Tomorrow morning, 80. Tomorrow evening, it got confirmed. Means here user is no way involved. Is happening, is running in the background. So that's why most of these financial applications, banking applications are batch applications. Generating credit card statements for millions of customers. Your user involvement is nowhere required. So Hadoop is meant for batch, not for online. Hadoop, Hadoop, if it is integrated, Hadoop if it is integrated with NoSQL. Hadoop if integrated with NoSQL, right? Hadoop if it is integrated with NoSQL, so it can perform both batch and online applications. And drawbacks with the current databases. Drawbacks with the current databases, right? See, why Hadoop is not using databases like for storing its data? What are the drawbacks you see means? Most of the databases, a limited storage you see, limited storage, that too in GBs or in TBs. But beyond that, unlimited data storage is not possible. And secondly, no parallel processing in most of the databases. In Hadoop, parallel processing, because of which very high speed you got. And let's discuss about this parallel processing. If volume increases, if the data volume increases, speed decreases, I'm saying. Speed is going to decrease. Observe this query, sir. Total amount from sales one. Total amount from sales one. 10 records you got. Total amount from sales 2, 1 lakh records you got. Total amount from sales 3, 1 crore records you got. Means here 10 records, 1 lakh, 1 crore. I want the total amount from sales 1, total amount from sales 2, total amount from sales 3. So here, if you observe carefully, a record to record means if we say query to query as volume increasing, so which query is going to execute faster among these three? Which query is going to execute faster among these three? Obviously, the first query, right? Total amount from sales one, total amount from sales one, which has got 10 records. Total amount from sales one of 10 records, right? As compared with 1 lakh or 1 crore, the first query execute faster, right? As compared with the other, right? Yes. Similarly, if complexity increases, speed decreases. If complexity increases, speed decreases. Yes. Complexity means total amount from sales one, average amount from the same table, sales one. Total amount from sales one, average amount from sales one, standard deviation of amount from sales one. standard deviation of amount from sales one. So here if you observe query to query, query to query, the complexity increasing. Speed means which query is going to execute faster among these three? Which query is going to execute faster among these three? Total amount from sales one, average amount from sales one, or standard deviation of amount from sales one. Means average amount is a two-step process. First sum to be calculated. First, right? Next average amount to be calculated. Next average amount to be calculated. Means as compared, right? The second query takes more time as compared with the first query. Here also the first query execute faster. Again, standard deviation of amount. Standard deviation of amount takes a lot of time as compared with the above two, right? And the major drawbacks with databases means it can handle only structured data. It cannot handle unstructured or semi-structured data. It can handle only structured data. It cannot handle unstructured or semi-structured data. The drawbacks of these databases. Before I go with the advantages of this Hadoop, going with the advantages of Hadoop. You need to know Hadoop follows client server architecture. Hadoop doesn't follow client server architecture. Means request response. If we are giving a request, getting the response, that is not the Hadoop architecture. Whenever anybody giving request, that is what web applications, right? But Hadoop follows master slave architecture. There will be a single master and multiple slaves will be available. Single master and multiple slaves available. Single master and multiple slaves. Cluster, okay, just observe this. This master, these are the slaves. Slave 1, slave 2, so on, slave n. This master node. This is master node. This is slave. S1, S2, S3 are the slaves. In Hadoop, this is called as a cluster. This is called a group of nodes connected in a network. Group of nodes. Nodes means CPUs. Group of nodes connected in a network. One master and remaining all will be the slaves. S1, S2 up to so m. So in Hadoop, always the data is stored in the form of files. f1.txt files. f1.txt files. This file is subdivided into blocks. The file is divided into smaller parts. Means if the file size is 2 TB and if the system each storage capacity is 1 TB, 1 TB, 1 TB. Each system hard space capacity is 1 TB. This 2 TB file cannot fit into any of the system. It cannot be accommodated by any of the slaves. So it will be divided, the file will be divided into smaller parts. The file is divided into smaller parts. Each part is going to be stored across multiple slaves. So data is distributed. Data is distributed across multiple systems, and data is processed by multiple systems parallelly. Data is distributed across multiple systems. Data is processed by multiple systems parallelly. Two advantages: distributed storage and parallel processing. Distributed storage and parallel processing. That is what you are going to observe here. So Hadoop follows master slave group of nodes. Nodes means CPUs connected in network. There are two types of node: master node and slave node. Master node responsibility and slave node responsibility. Master node will assign task to the slave as T1 task, T2 task, T3 task. So whatever data is stored here, executing the data is nothing but T1. Whatever data is stored here, storing in T3 task is nothing but whatever data is stored in this, executing that is nothing but T3 task. Data is split into smaller parts, stored across multiple systems and processed by multiple systems parallel. Yes. Master node responsibility, assigning tasks, the master node responsibilities. Task assignment. Task assignment means yes. Assigning tasks to the slaves. Load balancing. The task should be equally balanced to each and every slave. No slave has to be burdened. Fault tolerance means if multiple tasks are executed by multiple slaves, suddenly if any system goes down, then the task of it should be assigned to any of the other slaves. Who does this? Master. That is called fault tolerance. If multiple slaves are executed parallelly, suddenly if any slave goes down, then the task of it has to be assigned to any of the other available slaves. That is what fault tolerance. Health monitoring. Health monitoring means before assigning task to any slave, master node will have the capability, okay, or it will have the entire health status of each and every node before assigning the task, so that you will assign the task accordingly. Okay. Slave node responsibility only to storing the data, processing the data. Storing data within the slaves, processing data within the slaves, everything happens within this. Now coming to the Hadoop advantages. Unlimited data storage is possible in Hadoop because of horizontally unlimited scalability. Horizontally unlimited number of slaves can be added in the case of Hadoop, right? There is a limitation for the other things. If you're running a business if you're running a small business, here this is the master, these are the slaves. If you're running a business with 10 slaves also, Tomorrow, your business has increased, your customers have increased, your branches have increased, your data is increased. Means if data increased by 100 times, customers increased by 1,000 times, you cannot keep the same number of slaves. You need to keep on increasing, right? The data increasing, you need to keep on increasing the number of slaves. Horizontally, any number of slaves can be added. Okay, that is what? Horizontally unlimited scalability. Very high speed processing, very high speed processing because of parallel processing. 100 systems performing 100 tasks parallelly, parallel processing. The same one system processing all the 100 tasks one after the other, if each one taking 10 minutes, huge time it is going to take. But can handle all varieties of data, structured, semi-structured, and unstructured. Commodity hardware, right? Yes. Means this Hadoop can run on any hardware configurations. Doesn't mean that you need to have highly configured systems. No, it can run on anything. Open source, no licensing required. It is an open source, no licensing required. So main advantages of Hadoop: unlimited data storage, very high speed processing, parallel processing. Okay. So these are the main advantages, right? And why databases like Oracle won't support unlimited storage even in real time, right? Even in real time, Oracle can go with multiple slaves. Means maximum it can go with the 256 max limit databases and the max limit on the number of slaves nodes. Oracle it can go with max 256. Beyond that, it cannot. MySQL 54 nodes. MySQL Express 256. SQL Server 256. Teradata 512. Netija 512. Vertica 512 nodes. But currently Teradata and Netija they are supporting 1024. They are supporting 1024 nodes. Netija also supporting 1024, right? Teradata 512. Netija 512. Currently, they are supporting 1024 systems or nodes. But there is no limit. But here, if you talk about these databases, or specialized databases, there is a limit on this number of systems. But for Hadoop, there is no limitation. Horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. Okay. Yahoo, when first time implemented Hadoop, went with 4,000 nodes or slaves. Currently, Yahoo going with 8,000 slaves. Sorry, it's going with 12,000 slaves. Facebook, when first time implemented Hadoop, went with 8,000. Currently, Facebook going with 42,000 slaves for storing its data. That is what horizontally unlimited scalability. This is for storage point of view, Hadoop has proven in the market. Processing point of view also Hadoop has proven in the market by taking There's a test conducted. There's a test conducted. Right? There's a test conducted to check the speed of different databases. Taking a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. Time taken by different things. Oracle has taken nearly 3.5 days. MySQL has taken nearly 6 days. And Teradata has taken nearly 4.5 hours. Netija has taken 3 hours. Hadoop has just taken 4.2 minutes. The latest version of Hadoop has just taken 1.2 minutes. That is what Hadoop speed compared with the other things, right? Oracle has taken days. Netija, this MySQL has taken days. In the specialized databases like Teradata, Netija, they have taken hours of time. Time taken by Hadoop is in minutes, but by Teradata, Netija is hours, and Oracle and MySQL in days. Yeah. Even this is what the speed of what the speed of Hadoop. But if you see the speed of the speed of Hadoop, the speed of Hadoop is in minutes, just 1.2 minutes. But this hours, but this normal databases in days of time. Even though Hadoop has got very high speed, but if you see the Spark speed, the speed of Spark Spark is 100 times faster, 100 times faster than Hadoop. Hadoop already is very much faster, but Spark is 100 times faster than Hadoop. See the speed, of Spark. Okay. You see, like, what is Apache Spark? See, developed by Apache. Most of these Hadoop and Spark products are from Apache, right? So, yes. And why we need to go, actually, we have what Spark with Python implementation like PySpark. Need for PySpark. PySpark features. Real life usage of PySpark. Okay. Apache Spark, right? It is a open source. It's a cluster computing framework. It has been introduced by Apache. So I can say Apache Spark is a engine for general engine for big data analysis, processing and computation, processing and computation. Okay. Why PySpark means I can say PySpark is the Python API for using Spark. Python API for using Spark, right? Spark is an open source cluster computing, that as I said, which is used for big data solution. So PySpark today, I just see the speed, right? It's a lightning fast technology which has been designed for data engineers. Very demanding tool today among the data engineers to work with bigger data sets. Or if we say even in the Azure environment also, this Spark is used with has got very high speed. PySpark can be used for PySpark running distributed SQL, running distributed SQL, running distributed SQL, creating pipelines, creating data pipelines, creating data pipelines. What is that? What is distributed SQL means? So what do you mean by this? So here PySpark used for running distributed SQL means in Spark we have got the concept of data frames. Data frames and on the data frames you can create a temp tables and performing querying SQL kind of querying, right? Or creating temp table and performing SQL kind of query. Means even that is going to be stored across multiple systems. Stored across that data, whatever that is Spark object like data frames, all this were distributed across multiple systems. Means even you can perform SQL kind of queryings I'm saying, which are even though if this data is distributed, we can perform SQL kind of querying. Means creating data frames on top of the data frames, again, creation of temp tables and performing SQL kind of query. So in Spark, always the data is going to be running on the multiple systems. Means, for example, in a simple way, if you have got a TBs of data, if you are not splitting the data, if you are not distributing your data across multiple systems, if you are storing on only a single system, that system only need to store and that system only has to process, means takes a lot of time. So always Spark data is going to get distributed across multiple systems so that parallel processing is going to happen.
Sir, on what basis do we split the data?
See here, Spark, whenever by default, it is going to have that partitions. But even if you want to specify the partitions, if you want to specify the partitions, you can specify the partition, how many partitions you want.
Okay.
I want 10 partitions, please. Data will be distributed across 10 partitions, not on a particular column or anything. Data will be stored across multiple systems and processed parallelly, creating data pipelines, ingesting data into databases. Running ML.
So, sir, if I have 10 TB of data, so I will feed it into the master, and master would split it and spread it across the nodes, or
Yes,
would
yes.
there be anything else that
Any storage request, first it will has to go to the master only. Any storage request or processing request, first it has to go to master only. If any storage request, the storage will be it will be divided into smaller parts stored across multiple systems for parallel processing. And any processing request also, right? It will come to that master, is going to split the job into multiple tasks. Any job, right? It will be splitting the job into multiple tasks. The task will be assigned to multiple systems. They will running parallel.
And sir, you also said that if it is integrated with NoSQL, then it can perform both online and batch applications, right? So
Yes.
how do we do that? I mean, with the Hadoop, or it happens in PySpark?
So how we are going to integrate, we'll be discussing in this course.
Oh, okay.
We'll be discussing one NoSQL database also. I'll be discussing as part of this course. One streaming component I'll be discussing, and processing components, right? Two processing components, one storage component. Will be discussed as part of this. Ingesting data into database. Running MC Spark has got many libraries, powerful libraries, especially for running ML algorithms, for running ML, machine learning. Working with the graphs, working with the streaming, working with data streams, streaming the data, I can say, data which keeps data streams, data which keeps on generating, data which keeps on incrementing, such data we call like streaming data, graph data, ML, all these things, right? Spark has got special libraries like machine learning library, graphics library, Spark SQL library, data frame, right? All these things for creating data pipelines, running distributed SQL, ingesting data into databases, working with graphs, working with data streams. Right. Need for PySpark means huge data, right? It contains some market trends, customer preferences, unknown connections, some hidden patterns, and other useful business information. It is necessary to extract this valuable information from this raw data, right? So we require a efficient tool to perform different types of operations on this huge data. There are already various tools to perform these things, right? But those tools are not that much but handling this huge data. So so combining Python and Spark will be the very efficient way for the world of big data. So Spark is an execution model and Python is a programming language. So both combined together can store and that is what can process the data, right? As per that to it quick time, I said Spark is 100 times faster than Hadoop. Means even we require some Hadoop components. Even some Hadoop components we require today, both Hadoop and Spark combinedly, they are going to process. Okay. PySpark features means we've got many features, PySpark features, many PySpark features we have got. Especially in-memory computation. The main feature of PySpark is in-memory computation. In-memory computation. In-memory computation means if you've got a data object of 2 TB or means the 2 TB has to be stored in the memory itself, in the RAM itself. Within the 2 TB file means that much of RAM capacity we need to maintain for this. Storage happening within the RAM, processing happening within the RAM. That is what we call as in-memory computation. In-memory computation, not disk level storage, right? Yes. So in-memory computation is the main feature. And one more feature, what we see in PySpark. One more feature, what we see in PySpark. MPP. MPP. Massive parallel process. Massive parallel process. Parallel processing is going to happen, right? Huge data is going to be processed parallelly. When it is distributed, only parallel processing will be happening. If your data is going to be partitioned and stored across multiple systems, then only parallel processing can happen. If it is stored in a single system, no. Sequentially, you need to execute record by record. Okay, fine. One more feature. Partitioning means partitioning. Spark is going to, in partitions, data is to be partitioned, right? It's going to be multiple partitions stored across multiple systems. And one more thing is lazy evaluated. Lazy means lazy evaluated and active evolution. Active evolution means whenever you define immediately executing. Whenever you define something immediately executing, right? But lazy evolution means just like a function. Function you are defining, but if you're not calling it, it won't execute. Means whenever required on demand, you will be calling, making a call and execute. The same way here, our data flow, right? On demand, we are going to execute. If you are making answer, if you are just calling it on demand, we are going to execute. Until then, it won't execute. And that is what lazy evaluated is the best one as compared with active. It has got a powerful fault tolerant model. Has got the powerful fault tolerant model. Fault tolerant model means that's got powerful fault tolerant. Means as they are running on multiple machines, as it is running on multiple machines, if any one machine is going down, then the data is lost, right? But Spark has got the capability of regenerating the lost partitions. That is what fault tolerant. Later in the Spark we'll be discussing, right? One more feature, important feature, like persistence. Persistence means already you have executed some logic. That logic output again you can reuse it in that another flows. We need to can reuse it. The output of an Spark can be reused. Again, we don't need to re-execute those things. Already executed transformations output, already execution transformation output, you can reuse it without re-executing, right? So these are the main thing: massive parallel process, partitioning, lazy evaluated, in-memory computation, fault tolerance, right? So where this PySpark is used today, like in the banking sectors, financial sectors, to retrieve the customer's media profile, that is social media profile, analyze and gaining useful insights, which can help them in taking the right decision. Even in the healthcare, right? Even in the healthcare today, they are using this PySpark. So to identify or to predict who is going to face that issue, right? And also in the entertainment industry today, if we talk about this Netflix using this PySpark, right, for real-time processing. It processes nearly 450 billion events, 450 billion events per day. On server side application, right? Yes. And even in the e-commerce side, right? Like Flipkart, Amazon, all they're using Apache Spark for advertising, right? The other websites even they're using this for enhanced customer experience and optimizing the overall performance. Even in many areas, right, this PySpark is used today where for getting the very high speed. Wherever you want high speed, this PySpark, that too for huge data, right? For huge data in quick time if you want to process it. So PySpark, Spark with Python is the best way, right? Hadoop ecosystem components. Hadoop ecosystem. So first one, like one storage like HDFS. Hadoop distributed file system. It's a kind of file system. It's meant for storage. Second thing, pulling the data from different sources and where this HDFS can store this. And for a parallel execution model, MapReduce was used a lot previously, but the demand has decreased for it because of Spark. That is also meant for processing. Apache Hive. Apache Hive is also one of the important component of Hadoop. So this only if there are many jobs available only on Hive. So what good knowledge on this Hive, right? It uses HQL language. It's a data warehouse kind of environment. Data warehouse kind of environment means it has got HQL, Hive query language, which is similar to SQL, which is similar to SQL. So here we are going to make the data structured. If it is data in different formats, right? We are going to make the data structured. And loading the data into these Hive tables and performing querying. This HQL is similar to SQL, but this HQL can work with data like XML data, JSON data, the others data, right? Yes. And for performance tuning mechanism, we have got concept like um, partitioning. We have got the concept of seeing static partitioning, multi-column partitioning, dynamic partitioning. Okay. You have got concept like indexing, bucketing, combination of indexing and bucketing, combination of indexing and partitioning, combination of indexing and partitioning and bucketing, all the three for better performance, right? Yes. Another component, what we are going to discuss. Scoop. Scoop is nothing but SQL plus Hadoop. SQL, first two characters of this, last three characters of this. The first two characters and last three characters of this. Scoop for import or export operations. For importing or exporting operations. Import or export. Importing data or exporting data. See, importing data from different sources means pulling data from databases to this Hadoop environment. Exporting data after processing, you can export it to other things, right? Scoop is another component, important component. NoSQL database, as I said, a schemaless behavior, random access. Yes, record to record different number of fields can be maintained. As part of this course, I'm going to discuss HBase, Hadoop's database, and I'm going to discuss like Kafka, right? Yes, it's for streaming data which keeps on incrementing, which keeps on generating, so that you are going to extract it. And Zookeeper controls and coordinates all these above products. Yarn, yet another resource negotiator. Yet another resource negotiator. And finally, like a Spark, PySpark. Within this PySpark, you'll have got like okay. This PySpark has got components like PySpark SQL things, streaming things, right? So this PySpark will be spending more time for this PySpark. It has got great demand. Apart from this, some of the most used components, right? I'll be discussing. So this is the course content. You can check big data Hadoop. So in brief, in depth, will be discussed about these things. It won't be very complex. Simple things, HDFS, MapReduce, SQL plus Hadoop. Means the first two characters of SQL, the last three characters of Hadoop form scoop. So scoop importing and exporting. While importing, we can perform different operations while importing data from the databases to this Hadoop side, like filtering, merging, grouping, aggregations, defining scoop jobs, incremental loading or incremental import, groupings and aggregations. Yarn, yet another resource negotiator. That how this processing is going to happen, how the processing is going to happen, how the processing is going to happen, right? Yes. Within this yarn components, yarn architecture, everything I'll be discussing in brief. And I said I'll be discussing about a streaming component like Kafka. Even Kafka has got a great boom today, like so NoSQL databases, HBase, and coming to the Hive is one of the important component. Lot of discussion on Hive, differences between HQL, SQL, loading data from these external tables, structured XML data, JSON data, URL web block, Hive UDF, Hive UDAF, Hive UDTF, right? UDF, UDTF. Yes. PySpark. PySpark introductions. PySpark in brief we'll be discussing here, right? Okay. PySpark RTD computation, persistence options, PySpark core computations, groupings aggregations, various actions transformations, PySpark SQL data frame, different data frame, right? Like select, collect, group by, order by, join, rename, flat map for each simple PySpark SQL functions, PySpark built-in functions, one by one built-in functions of PySpark with working examples, PySpark external sources and deployment modes, PySpark applications, PySpark streaming, integration with Kafka and PySpark ML, right? And if you want, okay, with the Python, right? Python also in brief, it is going to be discussed. Python core and advanced, Python operations, operators, IDs, flow controls, looping statements, strings, collections, Python list, tuples, sets, dictionaries, functions in Python, modules in Python, packages, errors, exception, file handling, object-oriented programming concepts, regular IT, regular expressions, database connectivity, installation of one database, Python datetime, OS module, iterators, generators, closures, decorators, working with CSV, XML, JSON, graphical programming, Excel workbook, data analytics, right? Introduction to data science, Python, Pandas module in brief, NumPy module in brief, and Matplotlib, right? This all. So Hadoop, PySpark, Python, Linux. First, before I go with the practical, I'll be briefing about the Linux commands that are used before I go with HDFS. Yes. So I said you'll be getting the session videos for each and everything. Clear notes of this you will be getting for each topic. WhatsApp group will be created and assignments and tasks to work with. And the previously asked interview questions and resumes I will be providing writings. How exactly the data storage and data processing is going to happen? How exactly data storage and processing is going to happen is in the Hadoop environment? Yes. So how exactly the data storage is happening, I'll be discussing, right? Tomorrow also you can attend same time, right time. So tomorrow, yes, class at 3 p.m. Okay, 2:30 p.m. Class at 2:30 p.m. Right? Yes. How exactly the data storage? 2:30 p.m. 2:30 p.m. to 4 p.m. 2:30 p.m. to 4 p.m. I'll be discussing it. How exactly the data storage and processing is going to happen. So yes, understood, right? Yes. So that how exactly the data storage and processing is going to happen, how it is divided into blocks, how they are going to be processed, everything. I'll be discussing in the tomorrow 2:30 class, right? Fine.
Is
The
the
Same,
same classes?
same link you can follow. Same link you can follow for tomorrow. And tomorrow I'll be going with how exactly data storage and processing is happening, and what is replications in Python, fault tolerance in Python, and how many tasks in Hadoop, how many tasks depend, the task always depends on what. So those things I'll be discussing, right? Design principles with respect to replications, design principles with respect to HDFS blocks. Those things I'll be discussing, right?
Sir,
Okay.
is it the same batch last week happened today?
Yes, yes, yes.
Okay. You said you will move to 7 o'clock.
Hmm?
You said you will move to 7 p.m.
Yes. So and timings of this batch, right? Once again, I'm saying people. So for the first 2, 3 weeks, it will be for the first 2, 3 weeks, right? It will be at 3 p.m. It starts at 2:30 p.m., right? 2:30 to 4. Later, it will be at 7 p.m. 7 to 9. The timing of this batch will be shifted to 7 to 9. So before itself, I'm saying, right? So this week, next week also, it will be at same afternoon, but later it will be at 7 p.m. 7 p.m. right? In the evenings, Saturdays and Sundays. Right? Okay. So we'll meet tomorrow. More discussion on this. I'll stop for now, right? Follow the same link for tomorrow.